Hi, welcome to Finite Pi videos. This is DC here. In this video, I'm going to show you how to use UID changeable tags using the PN532 and the KeyDuino board. So these are the things I'm going to cover in this video. I've already made a video on how to use UID changeable tags using the ACR122 reader writer. So I would advise you to have a look at that. So because ACR122U also uses the same PN532 chipset internally, and the only difference between what you're going to see now and ACR122U is the way the command is sent. The ACR122 uses a concept called the sudo apdu, where the commands that are specific to the PN532 are embedded inside a frame, inside a fixed format. That's why it's called as a sudo apdu. So I'm going to use the PN532, which is connected in HSU mode using a simple USB to TTL connection. You're going to see how to write to block 0, and also you're going to see how to recover from a very bad block 0. So in other words, if you have a UID changeable tag which are not able to detect, so you're going to see how to fix it. And you're also going to learn a few new commands that are used, which is different from the one I have done in ACR122U. And it also works, whatever you see in this video will also work with the KeyDuino board, because the KeyDuino board also uses the PN532 reader writer internally. So if you go to my video channel in YouTube, and this video is fairly new, and this is the video that I have done. The screenshot and the look and feel of the screen is exactly the same as what you see in ACR122U reader writer. So if you have ACR122 reader writer, then I would advise you to see this video. And if you want to learn something more about UID and PN532, then this video is going to be useful to you. You can see here I've connected the PN532 board using the USB to TTL cable, and this is the software we have been using in all my videos on programming PN532, and this is version 1.7. The first thing you do is click, and at the bottom of the screen, which I can't show you here, you can see the version of the PN532 and what COM port is connected to. So I'm going to choose the UID changeable option, and this is the same tag I've been using since all my previous videos. The first thing you do is activate. I'm going to quickly go through these commands because I got so many videos explaining you what all this command does. Now this is the first two command is the standard the configuration, or in other words making the PN532 ready for accepting the external tags. It is the SAM config, and then I'm going to the number of tries you want the PN532 to do. So then this is the most important command, the inlist passive target. This is the command that will scan, that will look for any tags of type A, and if it finds one, the information about the tag is returned here. Now what you see here is the current UID of this tag. So in order to read the entire the block 0, and for a new tag, the password is all the keys are F's. So first thing is click on authenticate. If you look at the screen, this is identical to ACR122U. The only thing is we have learned something new in this video, so this is a bit tidier than ACR122U. Now if you look at here, so this is the standard, the authentication command, authenticate A, and after that we are reading the software reads the content of block 0, and which is showing here. So I'm going to change the UID to 90, say 919293, and you can also change anything here as well. So I'm going to clear. When you hit write block 0, so what has happened here is you have to first call this passive target. If you do not call, the write operation will not be successful, and you have to do that whenever you use this authenticate command. I've tried that, so it didn't work for me. Now this is the only thing different compared to ACR122U. So after that, these are the standard commands. I've explained this in my previous videos. The first is write register step 1, where you change the TX and RX mode. The next is send a halt command, and the next is setting the framework to 7 bits, and this is the most important thing, is the backdoor. So I think this command is what activates the card to accept all these type of writing to block 0. So these are called the backdoor command. And after that, we have to send one more write register command, then the backdoor command. So what interesting here is the backdoor commands are all sent using the in communication through command of PN532. So this is like bypassing like the firmware and passing the command directly to the tag. So after that, we have got, now the most important thing is the write block 0, and this is where all the thing happens. Now here in the write block 0, we are using the in data exchange command. See, this is a command that is in the firmware of PN532. So this command does does all the working, all the write operation to block 0. So after that, the software reads block 0, and this is how the software knows that the write is successful. It compares what is read and what has been written. If these two matches, the software shows this message, UID change OK, activate again if you want to see the new UID. Finally, you're going to halt this tag. Now this is exactly the same sequence of commands we have been using in the ACR122 as well. Now if you activate, see that the new UID is 9091. If you activate, you can see that it's 909192. Okay, that's very simple. So now I'm going to show you how to rectify from a bad block 0. So I'm going to change the UID, but this time I'm going to change by having the first byte as 88. And we have seen in my previous videos, the first byte 88 is not a valid UID byte 0. So if I write it, now it said the write is successful, and if you try to activate the tag, you will get error message. If you see that the in list passive target, which looks for the tag for type A, says it has detected 0 tags. Now it is because of the UID starting with 88. Now how to fix that? So the way you do that, if you're coming here without this screen open, the way you do is select this UID changeable. Now activate. You'll obviously get an error message. So not to worry about this error message. I'm going to change the UID I want. So I would like to have a valid one, say 45464748, and I'm going to set all this as 0. Okay, now this is where you're going to see some new commands we have used. So hit write block. Now this is a scenario where the PN532 doesn't know anything about this tag. So because of that reason, all these commands are sent using the in communication through commands. So this is like like a pass through or a transparent way of sending the commands directly to the tag. If you look at the sequence, Obviously there is no point in using enlist because it will never get recognized. All these commands are the same, the halt. So when it comes to the point where you write to block 0, if the tag was activated properly, you would have seen an in-data exchange command, whereas here we are using the in communication through. This is the write command, the MIFARE specific write command. To know what it is, look at this write command structure from the MIFARE classic document. Now this is the MIFARE write command. So it is done in two parts. The first part, you send the write command followed by the address, in our case block 0, and look for the response, and after that you send the 16 bytes of data and look for the response. So this is exactly what is used here, and we have to do that because the in-data exchange will never work. So you can see that. Now however, one thing I noticed is the response from this command is 02. Now 02 means it's a CRC error. So I'm not very sure why you're getting 02 instead of 00. However, it works for us. So in other words, you can ignore the response. You don't have to check for 00 here. Same thing happened for, if you look at the first command. So this is the 4A, sorry, this is the A0 followed by 00. That's the command. And this command is the second part of the command, which is just the raw data, that is from here to here. The 16 bytes of data is sent, and you just have to ignore the response. After that, again, in order to read, you cannot use the in-data exchange, the command from the firmware. You have to use the raw command defined in the command in the documentation. Look at the MIFARE read command, which is the command followed by address, and this returns the data and the CRC. And the command is 30. If you look at this, the command used here, it is 30 followed by 00, and you get the return is 16 byte of data, and this is compared with what is written, and for that reason, because these two compares, you're getting UID change OK. And if you activate now look at that, the write is able to you're able to write it. So this is how you can fix any errors in the block 0. Next, I'm going to show you how to use this UID changeable tag using the KeyDuino board, which I've connected here. And so in theory this should work because the KeyDuino board now is using PN532. It's exactly the same commands. Now connected here at the bottom of my screen, I can see the version of this PN532 board. I'm going to choose the tag UID. I'm going to place it right above this. Now I'm not using my external antenna, so to be careful, sometimes it might slip. Depends on what type of USB cable. I've got a very short cable, so it's just hanging. So activate. Okay, this looks like it's not in the right position. Yeah. Now authenticate. I think it's successful. You are able to read the block 0. I'm going to change this to 21. So we're able to change, and if you activate, you got this thing. Now this time I'm going to make it invalid, block 0, write. So activate, we got an error. I'm going to fix this, clear. So just scribble 2 bytes there and 2 bytes here. Right. Now if you read, and just to make sure the authentication works, I'm going to clear the screen. Read block 0, look at that. So it's pretty nice, just the same commands that work with the KeyDuino as well. So okay, this was a very short video, and I hope you learned a couple of new things, and thanks for watching.